Hello and welcome. When I first started working on this video, I had intended to isolate some solid sodium hexachloroosmate. However, in the process, I ended up making two completely different osmium compounds. One of them was ammonium hexachloroosmate, very small amount. The other is called osmium di-ammine hydroxide. This time around, I invested more osmium than usual. This dark, concentrated solution of sodium osmate contains about 40 milligrams of osmium. Before I can attempt to reduce this solution, I add ethanol to stabilize the sodium osmate. This changed the solution from a dark red to a dark purple. Once fully stabilized, I added hydrochloric acid in hopes that it would precipitate osmium dioxide. Unfortunately, I chose to add concentrated hydrochloric acid for whatever reason, and instead it produced chloroosmic acid, possibly also containing sodium hexachloroosmate. This is because while osmium dioxide initially did precipitate out, the solution was now so acidic that the osmium dioxide redissolved. At this point, I started getting really anal about getting osmium dioxide out of solution, so I tried adding sodium hydroxide to force it to precipitate out. After adding the first addition of sodium hydroxide, the solution was still so acidic that the osmium dioxide redissolved. At this point, I decided to just work with what I've got. Because technically this is chloroosmic acid, this is what I wanted to work with, and there may or may not be some sodium hexachloroosmate in there as well. So I decided to start boiling it down. You see, the issue is that there's already a bunch of sodium chloride in solution, and sodium hexachloroosmate is produced by the following reaction shown below on the screen. It stands to reason at this point there was sodium hexachloroosmate in solution. However, as it turned out, trying to obtain the solid by boiling it down was the wrong way to go. In fact, I'd previously read in the literature that it's formed upon evaporation with sodium chloride. So I was under, I guess, the mistaken impression that it doesn't form until it evaporates. However, in the middle of making this video, I stumbled upon a really hard to find article that gave me some further insight on this very subject. What seems to happen instead, upon boiling, is that sodium hexachloroosmate decomposes into sodium chloride and osmium dioxide. It was around this same time that I decided to try and check for osmium tetroxide vapors, but I couldn't detect any. Eventually, as more sodium chloride began to precipitate out of solution, the boiling action became so violent it would cause the vial to jump in the air. Obviously this was problematic, but I made some practical adjustments and soldiered on. Eventually a thick crust began to form around the rim of the vial. I collected this crust as it was rich in osmium dioxide. Looking at it under a microscope, it was indeed sodium chloride crystals chock full of osmium dioxide. After separating the sodium chloride precipitate from the rest of the solution, I made one last ditch attempt to obtain a hexachloroosmate salt. I decided to add ammonium chloride to the solution. If there's any sodium hexachloroosmate present, there will be a double decomposition reaction forming ammonium hexachloroosmate, which due to low solubility should crash out of solution. Because there wasn't enough solution to dissolve the ammonium chloride, I decided to dilute it with some water. Once all of the ammonium chloride had fully dissolved, a very small amount of a red precipitate began to form. This is ammonium hexachloroosmate. Oh my god, you can see it forming at the bottom. That is ammonium hexachloroosmate. I tried everything I could to extract every last particle of ammonium hexachloroosmate from this solution. But as it turned out, there just wasn't enough sodium hexachloroosmate in solution to precipitate any more. Although I'm a little disappointed with how little I was able to make, I still made ammonium hexachloroosmate, and it's definitely enough for you to see the vibrant red color it has. Looking back, I kinda wish that I had added ammonium chloride to this solution before trying to boil it down, and I'll definitely try doing that in a future video. However, I stumbled upon a different reaction. That is the reaction of excess ammonia with these hexachloroosmate solutions. Because the solution was already chock full of ammonium chloride, adding sodium hydroxide releases ammonia. Immediately, this produces a striking yellow color surrounding the solid sodium hydroxide. Slowly, the ammonium hexachloroosmate began to redissolve, and instead of the rest of the solution turning yellow, instead it turned the peach color. Only several hours later would it eventually turn back to yellow, before then turning brown and precipitating osmium di-ammine hydroxide. After isolating the first batch of osmium di-ammine hydroxide, I unfortunately haven't had any time to do anything else with the remaining solution, which has turned completely black and deposited a kind of osmium barcode on the side of the glass.